Hello, my name is Sam Foisey, and this presentation will be on hydraulic fracturing. Hydraulic fracturing is commonly known as fracking. It was founded in an experiment in 1947, and by 1949 it was used in commercial use. It is most commonly used in the oil industry. They use it to retrieve natural gas. Since 1949, it has been used almost 2.5 million times, but in the most recent years there has been a dramatic increase. The purpose of fracking is used to break apart the shale layer. It is used to release the natural gas that is not normally able to be mined. It makes these oil wells more productive and effective and allows the wells to produce oil for a longer period of time. These well sites can be found all over the world. In the United States, most are found in the lower 48 states. Well sites are found above deep shale layers that hold natural gas. These drilling operations can be found in rural areas, and they can also be found next to residential areas. They are most commonly found in the Pennsylvania and Texas area. On average, these well pads use only 7.4 acres. This map shows where the oil-producing shale layers are located in the lower 48 states. The fracking process is performed on the shale layer, which is found anywhere from 4,000 to 10,000 feet below the Earth's surface. The average fracked well is 600 feet below the surface. This is well below the drinking water aquifers, which can be found from 50 to 600 feet. The shale was formed in the Devonian Age, which occurred around 390 million years ago. It is formed from the settlement of ancient seabeds. The shale is normally found deep below the Earth's surface, but there are some found above the ground. The shale layer is made up from assortment of clays, for example, illite and smectite. Other fine particles such as phelps and quartz are found in the shale layer. The shale is normally a black or gray color, and this comes from the organic material that is found in it. These organic materials form the natural gas pockets over a long period of time. The natural gas pockets can make up 30% of the shale material by volume. These images are examples of shale rock. The left image shows three shales with different colors, and the right image is a dark black shale, meaning it has a high concentration of organics in it, thus meaning it is a suitable candidate to retrieve natural gas from. The shale properties that are looked for are: first, it needs to have a high concentration of natural gas, for example, ethane or propane. It also needs to be thermally mature. It needs to be porous, and it needs to be brittle. The natural gas concentration comes from the organic material found in the shale. It needs to be worth the expense of the fracking process. The shale also needs to be thermally mature. This happens over a long period of time when heat and pressure are applied to the shale. Also, the porosity of the rock layer is taken into account. Porosity is the ability for a liquid to move through the rock. The shale is normally not very permeable, and also the laminations affect the porosity. This is an example of the laminations in a shale layer. The laminations are formed by different settlement falling at different time periods. The laminations make it difficult for a fluid to flow through each different lamination layer. The brittleness of the rock allows the shale to fracture when under pressure. The more brittle the shale is, the less likely it will yield under this pressure. The image to the right is an example of a weak shale. As you can see, there are more clay particles than rigid particles in it. The rigid particles are not touching. Because they are not touching, when the pressure is applied, they will yield until they touch. This is an example of a strong shale. There are less clay particles than the example before it, and the rigid particles are touching one another. It needs a greater pressure to fracture, but when it fails, it will fail completely. The hydraulic fracturing steps. A well is drilled to below the depth of the drinking water aquifer. The drill is then removed, and the steel casing is lowered into it. Concrete is then pumped down the steel casing and pressurized so it fills around the outside of the steel casing. The drill is then reinserted down the shaft, and drilling is continued till 500 feet above the desired depth. At this point, a process called horizontal drilling begins. Horizontal drilling is a process of changing the direction of the drill bit. It takes up a few hundred feet to go from vertical to horizontal. It uses a hydraulic motor that is lowered down the shaft, and only the head of the drill bit turns. It allows fracking to be more effective and increases the target zone. They can drill in all directions from the well, and this allows them to drill under residential areas. This image is an example of a hydraulic drilled shaft underneath an area that is not accessible by the surface. Once the hydraulic drilling is complete, the shaft is then reinforced with the same method of using steel casing and concrete. The shaft is then plugged and ready for prep. A perforation gun is then lowered down the shaft, and the perforation gun has small charges on it that drill through the casing and into the surrounding shale. The perforation gun is then removed and the fracking fluid is pumped down the shaft, creating enough force for the rock to fracture. This process is then repeated until the entire horizontal shaft has been fractured. The image to the left is an example of the plug used. The image on the right is an example of the perforation gun and the charges going off, boring a hole through the casing and into the shale. This image on the left shows an example of how the shaft is plugged between fracture zones. The image on the right shows the natural gas flowing through the fractures and into the pipe. Once the entire horizontal shaft has been fractured, the plugs are then drilled out and the natural gas flows freely to the surface. When analyzing the fracking forces, if the pre-fractured shale is looked at on a particle-to-particle basis, it can be represented like the figure to the right. The fluid pushing in through the hole creates normal forces between each particle. It also creates shear forces in the opposite direction. The left side of the figure is the casing and can be considered unmovable. The forces created by the pressurization of the fluid push and pull the particles apart. The only direction for the particles to move is away from each other. Fluid causes small cracks in the rock, and they join together to become fractures. As the fractures move away from the source of the fluid, they get smaller and smaller. These fractures allow the fluid to flow back to the shaft when the pressure is released. The fracking fluid is made from mostly water. 1.2 to 2.5 million gallons is used during the fracking process, and once the pressure is released, only about 20% is retrieved. The fracking fluid also has chemicals in it. These chemicals are used to make the fluid more viscous. The viscosity of the fluid helps hold the propellants in place as they flow down the shaft. These propellants are used to hold open the fractures once the pressure is released. The most commonly used propellant is sand, and they range from a size from 2.3 to 0.1 millimeters. They are best when they are uniformly round and have smooth edges. The image to the right shows an example of propellants holding open a fracture and allowing the fluid to flow around them. As I mentioned earlier, the reason why fracking is used in the oil industry is because it makes the wells more productive. It also allows the oil companies to retrieve natural gas from rock layers that were not suitable for mining. There is less ground disturbance because these wells can be drilled horizontally, and these wells produce oil for a longer period of time